Ice is a mineral and a key component in the global climate system. Ice is the solid form of water and it melts at about 0 degrees Celsius at the Earth's surface. The higher pressure at the bottom of polar ice sheets, caused by the overlaying ice masses, can lower the melting point to -1 or -2 degrees Celsius. At the molecular level, ice is made up of a specific geometric arrangement of water molecules, a so-called crystal structure. There are at least 20 different crystal structures of water ice, but many of them can only form at very high pressure, such as in the interior of Jupiter's icy moons. To achieve such conditions on Earth, the polar ice sheets would have to be at least 10 times as thick. This is why on the surface of the Earth only the ordinary hexagonal ice exists. If you look very closely at the piece of ice, you can see the hexagonal ordering of the water molecules and understand where the hexagonal ice gets its name from. Other features of the structure include planes with closely packed molecules, alternating with planes with large distances between the molecules. For simplicity, a hexagonal prism is often used for representation. The z-axis is the main symmetry axis, and it is used as an indicator for the crystal's orientation. It is perpendicular to the basal plane. The hexagonal symmetry is also responsible for the symmetrical shape of snowflakes. A snowflake can be thought of as a single crystal of ice. Polar ice sheets are composed of many single ice crystals. This can be made nicely visible by having a look at a thin section of ice. A very thin piece of ice glued to a glass plate under polarized light. Fun fact, the glue of quartz are water droplets. The different colors occur because the refraction of light through the crystal depends on its orientation. The mechanical properties of ice also depend on the orientation of the individual ice crystals. Because of the arrangement of water molecules in the ice crystal structure, its deformation is easier along basal planes, like for a deck of cards. Determining the orientation of ice crystals is important for glaciologists to understand the flow properties of ice on a large scale. This is necessary to make accurate predictions about the ice sheet's evolution and sea level rise in response to a warming climate. I'm part of Deep Ice because ice is a beautiful and fascinating material to study.